Calculating normal distribution probabilities. So here we have a problem. The scores on a math test were normally distributed with a mean of 70 and a standard deviation of 10. So part A, we're supposed to find the probability that a student picked at random from the class will have scored from 65 to 87. So we're supposed to draw the normal curve, put the x-axis on there, the z-axis, and illustrate the 65 on there and the 87 and their corresponding z-scores. Then we're supposed to shade in the appropriate area corresponding to the probability asked for. Okay, part B is going to be kind of doing the inverse of that. If the teacher gives A's to the top 50% of scores, what is the cutoff for the student to get an A? Alright, so anyway, let's start with part A. So we have our distribution of test scores with mean 70, standard deviation 10. And we're trying to find what's the probability that a score will be between 65 and 87. Okay? So, what we always do first is draw an illustration. Now, this stuff I have below here is a bunch of theory, but basically all you're going to do is draw this kind of picture right here by hand. You're just going to draw a bell-shaped curve. You're going to put an x-axis on it, mark off your mean of your x's, mark off z-line, and of course 3 standard deviations away is way far out in a tail, and so your basic starting point is this, except for whatever problem you have might have a different mean. Okay, but this is the way this one is. Okay, now I just want to back up, and for those that are interested, I want to show you where that shape came from. Okay, it's a probability density function designed to give you a bell-shaped curve. Okay, and it's very special, called the normal bell-shaped curve, and it has this formula. Alright, so for our particular problem, we have a 70 mean, a 10 standard deviation, and a 10 standard deviation right there. So we put that in there. Okay, and e is that, exponential function e, about 2.7128 number. Okay, and so you would put, if you really wanted to graph that for real, you would put it in y1 like this, being very careful about these parentheses, careful about the parentheses in there, careful about this one and that parentheses, so that it accomplishes what you really want there. Then in the window, you would put 3 standard deviations below the mean, would be this one, so that's the standard deviation is 10, so 3 of those below 70, which is our mean, is 40, and 3 standard deviations above our mean is 70, so 3 tens above that gets up to 100. The scale, we want to go by the standard deviation, and then this would be hard to figure out, but I'm just going to tell you that the minimum y value to see this graph is 0, and y max would be 0.05, because the whole area inside here only adds up to 1, so it's a pretty short curve there. Alright, and if you did that and you pressed graph, this is what you're going to get, that curve right there. So that's your normal curve. Okay, so that's just a theory, but like I say, what you really would start with is hand drawing this bell-shaped curve, putting your mean there, putting a 0 standard deviation, because 70 is 0 standard deviations away from the mean, because it is a mean, and you'd have your z line here, which is your amount of standard deviations away from the mean and below the mean, and your actual raw data scores here, the scores on the test in this case. Okay, start with that drawing. Now, we want this. the probability that a score will be between 65 and 87 when the mean is 70 and standard deviation is 10. So we need to find some z values that correspond to those numbers. So the z formula is this. It's the number of standard deviations x is away from the mean. So you have this difference divided by the standard deviation. That gives you a z-score. So this is my own notation. Z sub 65 just reminds me that I'm presently calculating the z-score for the raw score x equals 65. That's 65 minus the mean over the standard deviation works out to negative 0.5. And the z-score for 87 is 87 minus the mean over the standard deviation, which is 17 over 10, which is 1.7. So those are the z-scores. Now, you put the x and the z info that you just got back on your drawing and shade in the area corresponding to the probability you want. And so here's what you're going to get. The 65 had a z-score of negative 0.5, and you just put it really precisely where it is. And the 1.7, a little close to 2, and that corresponded to a raw score of 87. And everything is looking good on the drawing, and the area between them is what we want, representing the probability that your x score is going to be between 65 and 87. So it's all this area here. Okay, since the area under the curve adds up to 100% or 1, then this area is a pretty big chunk. So we're thinking something over 50%, maybe 60%, something in there. It's a pretty big chunk. So we'll see exactly how much it is. Okay, so now that we have those z-scores, now we can just go ahead and use our calculator to find the actual area. Okay, because this is actually a calculus problem to find this area. Alright, so anyway, we do second vars to get that distribution menu, and you're going to choose the normal cumulative distribution function, the normal CDF, and it comes out looking like this. And so what you do is you erase this, clear that guy out of there, and put the lower is negative 0.5 and the upper is 0.7. So you are putting z-score info in here, not raw score. You could put raw score, but you should be thinking about z-scores, standard scores. Z-score info goes in here. See, it defaults to having a mean of 0. That's your, look where that is. See your z-score of 0, that is the mean for the z line, right? That's right in the middle there where the 70 is. And it's a standard deviation of 1 in the z line. See, it's 1, 2, 3. See that? So everything's converted over to standard scores. So you use z-scores for all 4 of these things. Okay, now note, depending on what calculator you have, you might not actually see this screen. You might see on the home screen normal CDF with a parentheses waiting for you to put something in. So you are going to put in negative 0.5 to 1.7 for mean of 0 and a standard deviation of 1 in the z-score. So you're just going to put that in and you're going to enter. Alright? If you're seeing this and you enter in this, then you arrow down to paste, and when you paste it you'll see this, the same thing as the other people saw, and then you're going to enter again, and you're going to enter this, and you're going to get this. So both kinds of calculators are going to end up with the same look here at the end. So there's your answer. So the probability that a raw score is going to be between 65 and 87 is about 64.69. Usually round these out to 4 places. And that's also 64.69% in case you want to view it that way. So that means 64.69% of the students scored from 65 to 87 on the test. It also means the probability that a student picked at random having a score between 65 and 87 is 0.6469. Alright, so that's this area up here. So that will be 0.64, what was it? 6469. 6469. That's what that area ended up being. Alright, so now we answered that question. Now for part B. Part B, still the same problem. The mean is 70, standard deviation is 10. We now need the X score for the top 15% of scores because the teacher in the story wanted to give those top 15% A's. So you draw a sketch. Okay, you have your X line, your Z line, your normal curve. You just draw it fast. Put this mean in there and the mean for the Z's, which is 0, there, right below it. And there's your 15% area that we want to come out with, and we put a question mark for the X and for the Z. We don't know what the Z and the X, this is what we're trying to find right here, these two things. Now, I put 0.85 area below here. Why? That's because the calculator method that we're going to be using, which is invNorm from the second vars is going to give us that. That needs areas to be stated as the area below the score you're getting. Area below. It's the area below the one you're looking for. So we're going to be putting in 0.85 area because that's how much area is below the Z score we're looking for if 0.15 is above. It's just a 1 minus idea. Okay, so you do the inverse norm. You go second vars, inverse norm, and you'll see this menu right here. Or if you have an older calculator, you'll see inverse norm on the home screen, in which case you put in inverse norm 0.85, that's the area, 0, 1. The area below where you want, and that's the Z mean, which is 0, and the Z standard deviation, which is 1. Okay, however, and then that's going to work. If your calculator does give this menu, then you put in 8.85, the 0 and the 1's already there, you arrow down to paste, and you enter it, and this is what you get. In both cases, you're going to get this, 1.036. Okay. Alright, so we have here that you have your 1.036, and we're going to round it off to 1.04 right over here. So we need the X score value corresponding to that Z. We now know that the Z we're looking for is 1.04, and that looks right because that's to the right of the mean, where it is reasonable that 15% of the area could be above there. Okay, so then you want the X. So X, Z formula is this. The X formula, algebraically manipulated a little bit, solving for X, is the mean plus Z sigma. It's the number of standard deviations away from the mean. So you put mean plus Z sigma, and that adds up to 80.4. You put that on the drawing. Okay, like this. Okay, 80.4. And that's your top 15% right here. That's the cutoff, 80.4.